Pretty good range.
All right. Today, we're going to take a look at some properties of trapezoids.
What is a zoid?
A trapezoid is a figure that has exactly one pair of opposite sides parallel. Right? Exactly one pair of opposite sides parallel. Any trapezoid, then, consecutive angles add to 180. So angles that are right next to each other have to add to 180. Okay? So these two angles would add to 180, and these two angles would add to 180. Bless you. Okay?
How do you know why would the two top ones at 180 and the bottom ones?
They just don't.
But how do you know if they're right next to each other then? Which ones are right next to each other? Because if you turn it, it's the same thing then, right?
So if we're looking at one pair of parallel sides, so we're essentially saying here's a pair of parallel sides, here's a transversal. These are consecutive interior angles, therefore they add to 180. Same thing over here. Here's a different transversal, so these two add to 180. But since these two sides aren't parallel, there's no relationship between these two angles or these two angles. Okay. So then we can go one step further and say if we have an isosceles trapezoid. Right now, isosceles we talked about with triangles, and that just means that we have two sides the same. So in an isosceles trapezoid, these two sides, which we call the legs, the non-parallel sides, those are congruent in an isosceles trapezoid. And then we have a few extra properties. Right? The diagonals are congruent in an isosceles trapezoid. The base angles are congruent. So what that means is these two angles are congruent to each other, and these two angles are congruent to each other. And then also opposite angles are supplementary. Okay, so in just a trapezoid, we really only have one nice property. Consecutive angles are supplementary. In an isosceles trapezoid, we can go a lot further. Okay, and say diagonals are congruent, base angles are congruent, and opposite angles are supplementary. Okay, so let's take a look at a few problems here and use those ideas. So in these first few, all we know is that this is a trapezoid. It's not necessarily an isosceles trapezoid. So the only property that we can really use is that consecutive angles are supplementary. So how would I figure out the measures of angles M and K here? To get K or M? To get M. So 180 minus 87 is 93. And then we would do the same thing over here to find K. Right? 180 minus 51 would get me 129 for angle K. Right? And then, one thing you can kind of do to double check yourself, make sure that those answers make sense, is add all four of them up and see if it adds to 360. All quadrilaterals, the interior angle should add to 360. So, we don't need to do all these examples. Let's skip number 2 and we can jump to the solving ones here. So for number 3, I know this angle over here is 54, and this angle is 8x plus 6. We need to set up an equation. What's my equation going to look like here? Right, those are consecutive angles, so I know they're going to add to 180. So we have 8x plus 60 equals 180. Let's subtract the 60 over, divide by and we get 15. Is that the final answer?
Yeah.
Alright, it just says solve for x. So, big idea for any trapezoid is that consecutive angles add to 180. Right? As long as they are on the same transversal. Right? We wouldn't say that these two angles add to 180 or these two angles add to 180. We have to be looking on, we extend out these parallel lines and draw the transversal between them. Right? This is a pair of consecutive interior angles. Right? So on the next view, we know that these figures are isosceles trapezoids. So we can go a little bit further. We can use those extra properties up top. So the first one, number 5, just asks which pieces are congruent. So it says DG is congruent to what, and DF is congruent to what. So first, DG is right here. If I know this is an isosceles trapezoid, DG would be congruent to what?
Yeah.
EF. And DF would be congruent to
EG.
EG, the other diagonal. We know legs are congruent and diagonals are congruent. So number 6 asks about the angles then. So angle T would be congruent to angle U, because we know that base angles are congruent in an isosceles trapezoid, and then angle V, angle W. So then these two here, finding missing angles, we're only given one angle for each of these. So if I know angle P is 112, angle Q would also be 112. Right? Then the other two would be 68, right? Because then I can say these two angles would have to add to 180. So I could say both of these would have to be 68 then. Questions so far? All right, let's flip over to the back then. Okay, and on the back, I believe all of these we're assuming it's an isosceles trapezoid, and we're just setting up equations to solve for missing pieces. So we're not going to do all these, but we'll do a couple of them. Let's take a look at the first one, number 9. So this is an isosceles trapezoid, and I know that MP is 16x minus 13, NO is 9x plus 8, PN, this diagonal, is 5y plus 19, and MO, the other diagonal, is 12y minus 37. So first, let's deal with x. How would I have to set up an equation to solve for x here? Right, these two sides are congruent. The two legs here are congruent. So I'm just going to set those expressions equal. Straightforward to solve then. Get the x's on one side. Get the numbers on the other. 5 by 7. X is 3. How about solving for y then? Exactly, set them equal, because I know the diagonals in an isosceles trapezoid are congruent. So I can say 5y plus 19 equals 12y minus 37. 7. Get y is on one side. 7/6 divided by 7. You get that y is 8. You okay with something like that? Okay. Why don't we take 4 minutes and you guys try the next couple of them here. Okay, the next few are dealing with some angles. So see what you can do to solve for some missing angles here. Alright, I know you probably don't have all of those done yet, and that's okay. But take a look up here at some answers for the ones that you did get done. Here's 10 and 11 and half of 12. That makes sense. That's good. So on 10, these two base angles are congruent, so I would set these expressions equal. On 11, consecutive angles are supplementary, so I would add them together and set that equal to 180. On number 12, if you got that far, that was pretty similar to number 11, actually. We just had to use the idea that since these two angles would be congruent, I could say this is also 6x minus 1. Then I can add these together and set those equal to 180. 13, the angles are congruent. And 14, just like number 12, I can say that if this is 3x plus 1, this is 3x plus 1, and then these would add to 180. Okay. Questions on any of those? All right. We've got one final idea. I guess I can just have you guys copy this down. Okay, the mid-segment of a trapezoid. So a mid-segment just says, I'm going to find the midpoint of this leg, and I'm going to find the midpoint of this leg, and I'm going to connect them. That's what a mid-segment is. Okay, so midpoint, midpoint, connect them. Two important properties. One is that the mid-segment is parallel to the other two parallel sides. Right? If I just find the midpoints and connect them, it is guaranteed to be parallel to these two sides. The other property we have is that the length of the midsegment is equal to the average of the two parallel sides. So I would add them together and divide by 2. So that that's guaranteed to be true, even if it's not an isosceles trapezoid, just any trapezoid. Right? Any trapezoid, the length of the midsegment is equal to the average of the two parallel sides. Right? So, let's use those ideas to look at some problems. So, numbers 1 through 4, it says, look at this picture here. So, for number 1, it says AB is 14, DC is 26, use that to find the length of EF? Well, I know EF is going to be the average of those two lengths. So EF is just going to be 14 plus 26 divided by 2. So that's 40 divided by 2 is 20. Pretty much. Okay. So let's look at number 3 though. We're given a little bit of different information. So on number 3, we're told we're given the length of the midsegment. Right? That's 22, and DC is 38. Yeah. I mean, we could set it up like this and say, 22 equals, I'll just call it AB plus 32 and solve that equation. Okay. Or we could just essentially subtract, right? All we're doing is saying, well, 38 minus 16 is 22. So if I subtract another 16, I'll get what AB is. 22 minus 16 is 6. So what were the shortcut here? So this is how we would set up an equation to solve, right? We're saying the length of the midsegment equals the length of the two parallel sides divided by 2. So we could solve this if we multiplied both sides by 2. We would get 44 equals AB plus 38. Subtract the 38, and we would get AB equals 6. If you want a shortcut, though, what we can do is say, if we're just dealing with numbers, right? If we have expressions, we'll have to set it up like this: the length of the midsegment equals two parallel sides divided by 2. But for a shortcut here, this number we know has to be the middle number in between these two. So all we're doing is saying, well, to get from here to here, I'm subtracting 16. So then if I do that again, I'll get that line. Yeah. So if we had AB in the midsegment, right, we could say, well, to get from here to here, I'm adding 16. So to get this side, then I would add another 16 and get 38.